In order to understand more about physics, integration is, or calculus is essential. But, you know, we don't have a whole semester to teach you math, so let me just give you a quick run through, or conceptual understanding on integral. Say if we have a time versus velocity. So we have a velocity that varies like this curve. So we want to know how much distance we have covered. We can think, we divide slices into so many small pieces. For this small pieces, delta t1, we can approximate thinking that at that time period, we have a constant velocity. So we only need to calculate the area. So basically, v1 plus delta t1, that's the distance we covered in this small time period. So again, we can just basically calculate the area of this rectangle instead of the curve and the rectangle. So that's a formal definition of integration. Basically, you integrate from t initial to t final, and integrate over the function vt with respect to time, like velocity with respect to time. So don't scare of this symbol because we don't need to worry too much about that for the purpose of this class. Only need to worry about that. Actually, that. So basically, I'm thinking an equivalent to all those small boxes add up together. So if the box is the slice is really thin, so we can think it's almost exactly the same as the area under the curve, right? So basically, if we, for some magical reason, we can use some papers and cut a paper like this shape, and we weighted how heavy it is, and then we know how heavy per area. So basically, we know the area of that. So basically, the distance we covered, or basically the integration, is the area under the curve, which is rather intuitive. And but of course, the curve, if we run backward, the distance we cover should be negative, right? So the area have a sense of positive or negative. If it's below the x-axis, it will be negative. Above, it will be positive. So we'll use that to calculate the average power.